Hello, my name is Ben Fletcher, and I am the working group lead for the CHERI and SoC working group of the CHERI Alliance. And today I'm going to give you an update on the working group. So I'm going to talk a little bit about what we're trying to do with the working group and also say what we've been up to, so the current activities and their status. So what's the working group's mission? Well, if you go to the CHERI Alliance website and look us up, you'll see that we're a working group that focuses on defining and standardizing what needs to be included in a system to support CHERI. So essentially, we're trying to make it easier for people to build CHERI technology into their systems. And we're trying to explain the complexities and challenges of integrating CHERI technology into a system so that the systems that are built are useful and correct. So as part of that, our main activity has been to create a document. So we have been trying to collate some material to build this document, this guide that people can use to ramp up in the world of building CHERI systems. So our guide is a starting point. We don't assume any prior knowledge. And as part of the guide, we've proposed some different levels of CHERI support for both IP and for systems. So we have a number of different levels of support, and the idea is that that can act as a bit of a steer for IP and system developers as what the combinations of features may be useful for them to include. And it can also help when people are trying to select IP to go into systems or select systems for products, to give an idea of a fair comparison between different systems. So the document itself, so it's been developed by the working group. It's only 13 pages long, so it's not too much of a big read. It is, as I said, it's self-contained, so it's a good starting point for someone who doesn't have any experience of CHERI to understand what's involved in building a CHERI system. It's been reviewed internally to the working group. We've also had some external review, and I've already used it with 2 external IP companies who were trying to work out what would be involved in adding CHERI to their portfolio. And so we shared the document to be a starting point for that, that investigation. The document, as I mentioned, defines different levels of CHERI support. So we've done this for IP and for systems. So I'll just run through quickly what those levels are to give people an idea. So if we think about the levels of IP support, so level 0, this is where we have no CHERI support. That's not the same as having no memory safety. It could be that you've got a piece of IP that includes a core, and that the compiler for that core may still be able to make some memory safety guarantees. But what we are saying is that there's no CHERI hardware in that IP. Level 1, well, this is where we do have CHERI hardware. So this is where we are providing basic spatial memory safety with that hardware. Now, temporal safety is still possible, but it would be with a stop the world phase. Level 2, so this is where we add in concurrent temporal safety. So for this, this would mean revocation happens concurrently with normal execution, but it's not going to be immediate. So use after free hazards are not protected against, if that's not guaranteed. An allocator can prevent use after reuse hazards. And level 3, the most sophisticated level that we've defined for IP, this is where we have hardware support for spatial and temporal memory safety. That means revocation is now immediate and use after free is deterministically trapped. On the system side, we've defined 6 levels of support. So it's a little bit more complicated because we've potentially got multiple IPs, and so we've got a few extra levels of support. But the least sophisticated is level F. This is where CHERI is just not supported at all. Level E is where there is some CHERI on the system, but the main CPU and accelerators do not support CHERI. So the kind of thing I'm thinking here is maybe you have a trusted element or a crypto engine that includes some kind of CPU core inside, and that CPU core inside is running CHERI, but your main CPU and accelerators do not. If we move to level D, this is the marker of this is that the system's main CPU and accelerators do now support CHERI. Level C, so becoming more sophisticated again, utilities can now be shared between multiple IPs. Revocation is performed using a stop the world phase in level C. Moving to level B, concurrent revocation is now possible without a stop the world phase on any of the IPs. And level A, our flagship level of support, revocation is possible across the IP block barrier. Immediate revocation is possible at the hardware level, and stick use after free protection. That is the end of my update. So thank you for listening.